So my immediate thought here is that I, once again, could arithmetize and make up a value for x to test this thing out. The danger of that is these exponents are really big. And I can't make up x as 0 or 1 like I normally would because 0 and 1 are not affected by exponents. But this question is very clearly testing exponents. So I need to make a number like 2, but even 2 to the 10th, it's kind of a big number. So I'm afraid something's going to get lost if I arithmetize. So I know I could, but this is definitely going to be a case where knowing the way that exponents work is much, much better. One other strategy that we should remember, though, is that we have answer choices. They're going to make you try to do harder math sometimes by making you go forward through a question, right? If we go forward through this, we have to factor, and that's a difficult move in math. That's a division move. Whereas if we look at the answer choices and try to work them backwards, now we can distribute. Distribution is multiplication. Distribution is a much easier way of thinking about algebra. So I'd rather do that. And so let's think about what would happen if we distributed this x. Well, if I distribute it to this first part, I would get 7x to the 11th, right? Because the 7 doesn't change. There's a number in front of this x as well. It's 1, so 1 times 7 is 7. The x adds in another exponent there because x to the 10th is x times x times x 10 times. So if I throw in another x, that's now an 11th time, right? So that's what an exponent does. It's all multiplication. It's just a shorthand for a bunch of multiplication. So 7x to the 11th is not anywhere in here. So that's no good. Now, if I do that here, I would have 8 to the 10th times x because now the exponent's on the wrong thing, right? In the equation that we were originally given, the exponent is on the x. You can't just move it to the 8, right? That's a different number. So 8 times 8 is like, let's say 2 to the 3rd, right? So that we could do, that's a switch we could make, but that's not what's happening here. 8 versus 8 to the 10th are completely different numbers. I don't even know if 8 to the 10th is going to show up in the calculator. It's probably so big. So this is just misinterpreting how exponents work and allowing you to move them. The exponents here are on the x's, not on the 8s, not on the coefficients. So C, if we multiply this in, we would get 8x to the 11th, right? Because the 8 multiplies by the 1 that's in front of that x to the 10th. And then again, when we are multiplying things that have the same base, we add the exponent. So the x to the 10 has another x kind of multiplied in, so now that's 11x's all multiplied together. So that doesn't look right because, right, it's supposed to be x to the 10th. So there's no 11th. So hopefully it's D, right? If we multiply that in, we get 8x to the 10th, so that looks good. Minus 8x to the 9th, right? So now we have x to the 8th, and then another one thrown in is now 9 plus 88x just by itself, right? Because now the x is not multiplied by any more x's, so it just stays x to the first, but now the 8 and the 11 get to multiply to 88. So that was long-winded. I would hope that, by, let's say, 9th grade, you know that kind of level of algebra. That's very fundamental. So if you struggled with this question, you don't know algebra as much as you need to for the higher level SATs and PSATs that you're going to be taking. So make sure that you stay on top of your math in school and make sure you understand how different variables behave when we're using exponents, multiplication, all the different operations.